Cosmic dawn. The origins of galaxies and the beginning of everything. Before there was light, there was silence. A silence so vast and complete that even the concept of time had not yet begun to move. The universe existed as a formless haze, an ocean of invisible matter suspended between being and nothingness. There were no stars, no galaxies, no color. Only the faint echo of an explosion that had already changed everything. The Big Bang. But the Big Bang was not the moment of light. It was the moment of potential. What followed was a long cosmic night, hundreds of millions of years when darkness ruled and the first stars had not yet been born. The universe expanded quietly, cooling and thinning, like a deep breath held in anticipation. Then, somewhere in that endless void, gravity began its patient work. Tiny fluctuations in density, imperfections in the cosmic fabric, started pulling hydrogen and helium together. Slowly, invisibly, the first clouds of gas grew heavier. Within those clouds, atoms collided, pressure rose, and heat began to build. The darkness trembled. And then, in an instant that changed everything, the first light broke free. That moment is what scientists call the cosmic dawn, the awakening of the universe. The first stars ignited like sparks in the void, transforming cold space into something alive with energy and color. Light spread across the darkness, and for the first time, the universe could see itself. These were no ordinary stars. They were titans, massive, unstable, short-lived. They burned hotter and brighter than any that exist today, living only for a few million years before collapsing in violent explosions. But their deaths were not endings. They were beginnings. In those explosions, heavier elements were forged: carbon, oxygen, iron, the building blocks of everything that would follow. Every atom in your body was born in those first fires. You are, in a literal sense, made of the universe's first light. From the ashes of those first stars came the seeds of galaxies, immense structures of gas, dust, and gravity that would grow to hold billions of stars each. The universe, once formless and dark, began to weave itself into something structured, elegant, and alive. And yet, for all our technology and telescopes, we still cannot see this era directly. The light from the cosmic dawn has been stretched by billions of years of expansion, shifted into faint radio and infrared whispers that only the most sensitive instruments can detect. We are trying to see not just the past, but the moment when the past became visible. Every beam of light that reaches us from that ancient age is a messenger, traveling for more than 13 billion years to deliver the story of the universe's first awakening. It tells us how the first galaxies formed, how gravity sculpted chaos into order, and how creation itself began its long experiment with life. The cosmic dawn is not simply the beginning of stars. It is the beginning of meaning. The moment when matter learned to shine, when darkness was no longer alone, when existence first took shape. Stay until the end, because this story is not about something that happened long ago. It's about something still unfolding. The same laws, the same patterns, the same forces that once brought light to the universe are still shaping us now. The dawn never ended. It only changed form. If this story already speaks to something ancient inside you, stay. Subscribe, not for answers, but for the questions that awaken wonder. Here, we don't just watch the universe. We remember that we are part of it. Share this journey with those who still look up, because the dawn of understanding is only just beginning.
The long night before the first light. Long before the first stars burned, the universe was a place of silence, a vast expanse without color, light, or structure. It had already been born, but it had not yet awakened. Astronomers call this era the Cosmic Dark Ages, and it remains one of the most mysterious chapters in existence. Roughly 380,000 years after the Big Bang, the universe had cooled enough for atoms to form.
The blinding radiation of creation faded, leaving behind a fog of neutral hydrogen that filled all of space. There were no suns, no galaxies, no glimmers in the dark, only an ocean of invisible gas stretching endlessly in every direction. The universe was transparent, yet perfectly black. In that eternal night, gravity began its slow, deliberate work. Imperfections, tiny ripples in density left over from the Big Bang, became the seeds of structure. Where there was slightly more matter, gravity pulled harder, drawing gas into clumps. Over millions of years, these clumps grew denser, merging into vast clouds of hydrogen and helium. If you could have stood there, suspended in the dark, you would have seen nothing. But you might have felt something. The faint hum of motion, the universe gathering its breath. It was a silence full of potential, a stillness about to break. Inside those ancient clouds, heat began to rise. Particles collided faster and faster, friction building with every compression. The invisible was beginning to glow, though not yet with visible light. It was radiation in its infancy, the first whispers of energy struggling to be born. But this process was slow, agonizingly so. For hundreds of millions of years, the cosmos remained hidden, blind to itself. Time passed without measure, and the universe waited. During this long night, only one faint glow lingered, the afterlight of the Big Bang, known today as the cosmic microwave background. It was the echo of creation, stretched thin by expansion, fading, but never gone. It carried the memory of everything that had come before, the heat, the density, the pulse of the first moment. Scientists studying this faint radiation have mapped the tiny variations in temperature across the sky. Those variations, just a few millionths of a degree, are the fingerprints of the first gravitational seeds, the blueprint of every star, every galaxy, every future world. From randomness came pattern, from darkness, the architecture of light. And still, the universe was cold. The hydrogen fog absorbed every photon that tried to escape. Light could not yet travel freely. It was trapped, scattered, swallowed. Space itself was expanding faster than gravity could gather it. The struggle between chaos and order had begun, and it would take another 200 million years before the first victory. In that time, the universe grew to nearly its present size. The great cosmic web began to form, threads of dark matter weaving the scaffolding upon which galaxies would one day hang. These invisible structures were already shaping the future, even though nothing could yet be seen. To call this era dark is both accurate and deceptive. Yes, it was lightless. But it was also fertile. Every atom, every force, every future star existed within that darkness, preparing for ignition. The silence was not emptiness, it was anticipation. And then, somewhere in that vast night, gravity reached its tipping point. One of those hydrogen clouds became dense enough to ignite nuclear fusion. The first star was born, a single flare of light against an ocean of black. That light marked the end of the cosmic night. But it also marked the beginning of something even greater, the birth of identity. From that first spark forward, the universe would never again be the same. The birth of the first stars, fire from nothing. Somewhere within the black silence of the early universe, a single spark ignited. Then another, and another. From nothing but hydrogen, gravity had conjured the first flames. The darkness that had lasted for hundreds of millions of years was finally broken. The cosmic dawn had begun. The first stars were nothing like the ones we see today. They were giants, enormous short-lived titans known as population 3 stars. Composed almost entirely of hydrogen and helium, they lacked the heavier elements that make up modern stars. This purity made them burn hotter, brighter, and far more violently. Some were hundreds of times more massive than our sun, their surfaces blazing at temperatures unimaginable to us. Each of these early stars formed deep within a collapsing cloud of gas. As the cloud's core grew denser, its temperature soared until hydrogen atoms began to fuse into helium. The moment that creation became illumination. For the first time since the birth of the cosmos, energy was released in the form of light. But these first suns were unstable. Their gravity battled constantly against their internal pressure. The larger they grew, the more quickly they consumed themselves. In a few million years, an instant on cosmic scales, they reached their limit. Many collapsed into black holes, their cores crushed into points of infinite density. Others ended in spectacular supernovae, explosions so powerful they could outshine entire galaxies. In those deaths, the universe was reborn again. The explosions scattered heavier elements, carbon, oxygen, nitrogen, iron, into the surrounding space. These were the first seeds of complexity, the raw materials for planets, oceans, and life. Every breath you take contains atoms forged in those early stars. The calcium in your bones, the iron in your blood, all born from ancient fire. Astronomers call this transformation cosmic enrichment, the moment when the universe began to diversify its chemistry. Before this, existence was simple, just hydrogen and helium. Afterward, it became infinite in possibility. The radiation from these stars also began to reshape the universe itself. Their ultraviolet light tore through the fog of hydrogen that had kept space dark, splitting atoms apart and clearing the cosmic mist. This process, known as ionization, turned the opaque universe transparent. Light could finally travel freely, revealing the first structure of the cosmos. From that moment on, darkness would never again have complete dominion. Modern telescopes like the James Webb Space Telescope are now catching glimpses of this distant dawn. Each faint, red-shifted galaxy it observes carries photons that have been traveling for over 13 billion years, the light of the first stars, stretched by time and space. When we capture it, we are literally seeing the universe's first awakening. But the mystery remains. How did such massive stars form so quickly? The early universe was a hostile place, expanding rapidly, filled with radiation, lacking metals to cool collapsing clouds. By all logic, star formation should have taken longer. Yet the first stars appeared almost immediately after the Dark Ages. Perhaps gravity itself was more efficient back then, or perhaps unknown forces accelerated creation. Some even suggest that dark matter, the invisible scaffolding of the cosmos, guided the formation of these first stars, pulling gas into the densest regions of the early universe. Whatever the cause, their light changed everything. The universe, once silent and shapeless, now pulsed with energy. These first fires were the heartbeat of creation, brief, brilliant, and essential. And when they died, they left behind something even more mysterious: the seeds of the first black holes. Giants that would one day shape galaxies, bend space, and rewrite the laws of time itself. The darkness had returned, but this time, it was different. It was a creative darkness, one that built as much as it consumed. The death that created life. The first stars did not die quietly. They ended their brief lives in cataclysms so powerful that they reshaped the universe itself. Their explosions were not acts of destruction, but of creation. From their death came everything we know, every element, every planet, every possibility of life. When a massive star reaches the end of its fuel, gravity wins. The outward pressure from nuclear fusion that held it stable collapses, forcing its core to implode. In a fraction of a second, temperatures rise to billions of degrees, and the outer layers are hurled into space in a supernova, one of the most violent events in the cosmos. These first supernovae marked the end of the pure hydrogen universe. In their cores, atoms fused into heavier elements: carbon, oxygen, silicon, and iron. When the stars exploded, they scattered those elements across space, enriching the cosmic gas from which new generations of stars would form. The universe, once simple, became complex. From those ashes, the first planets could be born. You carry that story inside you. The calcium in your bones, the oxygen in your lungs, the iron in your blood, all were created in those ancient explosions. Every heartbeat is a rhythm written by stars that died billions of years ago. But not every star met the same fate. Some were so massive that even the explosion couldn't halt gravity's collapse. Their cores imploded into black holes, points so dense that not even light could escape. These black holes became the dark hearts of the early universe, devouring matter and growing rapidly. They would later become the anchors around which galaxies formed, invisible architects of cosmic structure. Astronomers call this period the era of Ryanization, the moment when light returned to the universe and reshaped it. As the first supernovae detonated, they unleashed energy that stripped electrons from atoms, transforming the fog of hydrogen into a transparent sea. The darkness lifted. The cosmos could finally see itself. Yet, even in this age of light, mystery reigned. How did the first black holes grow so quickly? Observations reveal that some reached millions or even billions of solar masses in just a few 100 million years. By all known physics, that should be impossible. Something, perhaps an unknown mechanism of gravity or a hidden role of dark matter, accelerated their growth. The early universe was not only beautiful, it was strange. Still, the pattern was clear. Every end became a beginning. The death of stars created the raw materials for everything else. The collapse of matter into darkness gave rise to the structures of light. The cycle of creation and destruction was not a tragedy. It was the heartbeat of the cosmos. The cosmic dawn was not a peaceful awakening. It was an age of fire and violence, where death was the only path to renewal. Each explosion was a declaration that even in destruction there is creation. And from the chaos of those early deaths, a new form of order began to emerge. Galaxies, immense cities of light and gravity, drawn together by the invisible forces seated in that first generation of stars. The darkness had returned once again, but this time it had purpose. The universe was building something. The first galaxies, architects of the infinite. From the ashes of dying stars, the universe began to build its greatest structures, galaxies. They were not designed, yet they formed with astonishing precision. Born from chaos, they became the architects of the infinite, shaping the cosmos into the grand design we see today. The first galaxies were small, fragile things, clusters of newly formed stars bound together by gravity. Astronomers call them proto-galaxies, and they appeared when the universe was only a few 100 million years old. Each one contained just a few million stars, but those stars burned fiercely, flooding their surroundings with radiation and heat. Gravity was their engineer. It pulled together dark matter, gas, and dust into dense halos, invisible scaffolds that held the luminous stars in place. Without dark matter, galaxies could never have existed. It was the unseen hand guiding everything, the silent framework upon which creation could take form. As these young galaxies grew, they began to merge, colliding and combining in vast cosmic dances. Each collision sparked bursts of new star formation, igniting fresh waves of light across the universe. Over billions of years, these mergers built the great spiral and elliptical galaxies we see today, systems of breathtaking complexity, each containing hundreds of billions of stars. Our own Milky Way began as one of these early proto-galaxies. It was born in the same chaotic age, built from countless smaller mergers that left behind streams of stars still visible in our sky. Every galaxy carries scars of its origins, faint trails of matter, ancient collisions, and the quiet signatures of forgotten beginnings. But galaxies were more than just collections of stars. They were engines of transformation. Within them, gravity compressed gas into dense molecular clouds, giving birth to new generations of stars. The death of one generation fueled the birth of the next. Over time, galaxies became self-sustaining ecosystems, cosmic cities where matter, light, and energy cycled endlessly. And yet the mystery of their formation remains unsolved. How did the first galaxies appear so quickly, so early in cosmic history? Observations from the James Webb Space Telescope have revealed galaxies forming far sooner and far brighter than theories predicted. Some existed just 300 million years after the Big Bang, glowing with impossible intensity. If these findings hold true, our understanding of cosmic evolution must change. It suggests that the early universe was far more efficient at creating structure, that gravity, dark matter, and radiation worked together in ways we do not yet understand. Perhaps the very laws of physics unfolded differently in those first moments. Each galaxy that emerged was a declaration of order, a rebellion against the void. Their formation transformed the universe from emptiness into architecture. They became the fundamental units of cosmic identity, each one a living system, each one carrying its own history of creation, destruction, and renewal. And within their hearts, something extraordinary began to take shape. Vast wells of gravity so powerful that not even light could escape. The first black holes, silent engines that would one day define the structure and destiny of the cosmos. The same forces that built galaxies also summoned darkness. The universe was not content with light alone. It needed balance, creators and destroyers, expansion and collapse. The dance of opposites had begun, and its rhythm would echo for eternity. The birth of the first black holes. As galaxies began to take form, a darker and more mysterious force awoke within them. Black holes. Born from the deaths of the first stars, they became the silent architects of the cosmos, shaping the galaxies that surrounded them and defining the flow of matter, energy, and even time itself. The first black holes emerged in two ways. Some were the remnants of massive stars that collapsed under their own weight after supernova explosions. Others, far stranger, may have formed directly from the collapse of dense gas clouds, skipping the stage of star formation entirely. These are known as direct collapse black holes, and they could reach millions of solar masses almost instantly. But how did they grow so fast? That question remains one of cosmology's great enigmas. Observations have revealed supermassive black holes, some billions of times the mass of our sun, existing less than 1 billion years after the Big Bang. According to conventional physics, there hasn't been enough time for them to form through gradual accumulation. Something in those first cosmic centuries was accelerating their birth. One theory suggests that regions dense with dark matter may have provided the perfect conditions for rapid growth. The unseen gravitational scaffolding could have funneled gas directly into the centers of young galaxies, feeding their black holes with astonishing speed. Another possibility is that early black holes merged frequently, combining into ever larger singularities during the chaotic era of galactic collisions. Whatever the process, these early titans changed everything. Their immense gravity didn't just consume matter, it organized it. Around them, gas and dust spiraled inward, forming accretion disks that burned brighter than entire galaxies. The energy they released shaped the galaxies themselves, regulating star formation and dispersing gas through powerful winds and jets. In this way, black holes were not destroyers, but sculptors. They carved galaxies into the shapes we recognize today: spirals, ellipticals, and clusters bound together by their invisible influence. Without them, the universe might have remained formless and chaotic. And yet, black holes embody the greatest paradox of creation. From the outside, they appear as voids, regions from which no light escapes. But within them, gravity and energy reach unimaginable extremes, where the known laws of physics collapse. Space and time curve into a single unknowable point, a singularity. To many scientists, black holes are not merely objects, they are gateways to the unknown. Some theories suggest that their interiors could connect to other universes or birth new realities beyond our own. If so, every galaxy might contain a doorway, a link between creation and infinity. Even today, their influence is written across the cosmos. At the center of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. The one at our center, Sagittarius A, weighs 4 million times the mass of the Sun. It is quiet now, but once it was as bright as a quasar, a cosmic beacon visible across billions of light years. Black holes began as a byproduct of death, but they became the engines of cosmic evolution. They remind us that creation and destruction are not opposites. They are partners. The universe builds through collapse, and in the heart of every ending lies the seed of something new. The first black holes did not just consume the light around them. They shaped the future of the cosmos, pulling galaxies into order, anchoring time, and defining the rhythm of eternity. And soon, they would help weave something even greater, an invisible structure that connects everything in existence, the cosmic web, the hidden skeleton of the universe. The Web of Light: How Galaxies Learned to Connect. As the first galaxies settled into form, a grander pattern began to emerge, a structure so vast that it defied imagination. The universe, once a scattered collection of stars and gas, was becoming something connected, alive, and deliberate. Across billions of light years, gravity was weaving galaxies together into a colossal network, a web of light stretching through the cosmos. This cosmic web is the largest structure ever discovered. It is the framework of the universe itself, an intricate lattice of filaments, clusters, and voids. The glowing threads we now see through telescopes are galaxies and galaxy clusters, bound by the invisible glue of dark matter. Between them lie immense cosmic voids, expanses of near emptiness spanning hundreds of millions of light years. If we could step outside the universe and look back at it as a whole, we would not see a random scatter of stars. We would see a vast, shimmering network, a neural pattern of creation, pulsing with energy and light. It looks eerily like the web of neurons inside a human brain. The same balance between chaos and order, between emptiness and connection, governs both. The origins of this web trace back to the smallest fluctuations in the early universe, tiny variations in density, barely perceptible in the cosmic microwave background. Over billions of years, gravity magnified those differences, pulling matter toward the denser regions while leaving others empty. What began as faint ripples in a sea of particles became the scaffolding of galaxies. The luminous threads of the web are made not only of stars and gas, but of something far stranger, dark matter, the invisible majority of the cosmos. It neither emits nor absorbs light, yet it shapes everything that does. Dark matter formed the backbone of the universe long before galaxies appeared, and ordinary matter simply followed its lead, gathering along its hidden filaments like dew on a spider's thread. This invisible network is not static. It moves, flows, and evolves as galaxies migrate along its paths. Gravity acts like a cosmic current, drawing matter through the filaments and feeding the vast clusters where galaxies gather by the thousands. Those clusters, in turn, send shockwaves of energy back through the web, a living exchange that has continued for over 13 billion years. Astronomers today can see this structure using powerful simulations and deep space surveys. What they find is astonishing. The universe has the same fractal rhythm at every scale. From the dance of galaxies to the motion of atoms, the same pattern repeats. Structure begets structure. Order emerges from randomness. The universe is self-similar, a cosmic echo of itself. And at the intersections of this web, where filaments cross and converge, lie the brightest galaxies, the most massive black holes, and the most intense bursts of star formation. It is as if the universe itself concentrates awareness at its points of greatest connection. The cosmic web is not merely a physical network. It is the story of how the universe learned to organize itself. From simplicity came complexity. From chaos came design. It's a mirror of the same process that shaped life, consciousness, and civilization, systems that grow by connecting, by weaving patterns out of emptiness. We are part of that same structure. Every atom in our bodies, every neuron in our minds, every idea that links us to one another is a continuation of the universe's oldest instinct, to connect. But connection has its limits. The web, vast as it is still expanding. The galaxies are moving apart faster and faster, driven by a mysterious force we call dark energy. One day, that acceleration may tear the web apart, leaving each galaxy isolated in eternal night. The universe may once again return to silence. Yet for now, the web still shines, a cosmic nervous system linking billions of galaxies, each one a spark of awareness in an infinite mind. The invisible builders, dark matter, and the hidden scaffolding. The universe we see, the stars, the planets, the glowing galaxies, is only a fraction of what exists. Everything visible, everything that shines, makes up less than 5% of the cosmos. The rest is unseen, untouchable, yet it holds the universe together. This hidden majority is dark matter, the invisible scaffolding upon which all of creation is built. Dark matter does not emit light, reflect it, or absorb it. It cannot be seen, even with the most powerful telescopes. Yet its gravitational pull shapes the cosmos on every scale. It was the first to form structure after the Big Bang, collapsing into vast halos long before atoms, stars, or galaxies existed. Those halos became the cradles where ordinary matter could gather, cool, and ignite into light. Without dark matter, the universe would never have learned to shine. We don't know what dark matter is made of. It could be composed of undiscovered particles, remnants from the earliest moments of creation, or something even stranger, a new form of matter that exists beyond the reach of our physics. For now, we know it only by its influence. We can see its presence in the way galaxies rotate, in the way light bends as it travels through space, and in the grand cosmic web that stretches across the universe. In the 1930s, astronomer Fritz Zwicky first noticed something strange. Galaxies and distant clusters were moving too fast to be held together by the visible matter alone. There had to be more mass, something unseen, providing the necessary gravity. Decades later, Vera Rubin confirmed this by studying spiral galaxies. Their outer stars moved just as quickly as those near their centers, defying Newtonian expectations. The explanation was clear. Invisible matter was holding them in place. Since then, dark matter has proven indispensable to every model of cosmic evolution. It acts as the framework of existence, a hidden architecture that shaped galaxies, clusters, and the cosmic web itself. Its presence is so dominant that without it, the universe as we know it could not exist. But if dark matter builds, there must be something that balances it, a counterforce that tears structure apart. That opposite is dark energy, the mysterious agent of cosmic acceleration. Together, these two unseen entities control the fate of everything. One binds the universe, the other drives it apart. They are the yin and yang of cosmology, creation and expansion, gravity and release. Dark matter's influence extends far beyond the galaxies we can see. Its halos stretch for millions of light years, invisible cocoons of gravity that cradle the stars within. When galaxies collide, their dark matter halos merge first, setting the stage for the luminous dance that follows. Even when the stars are torn apart, the dark matter remains intact, the silent survivor of every cosmic catastrophe. Some physicists believe dark matter could be more than just matter, that it might interact with itself in unknown ways, forming structures, waves, or even dark stars made entirely of unseen particles. Others propose that what we call dark matter is not matter at all, but a sign that our understanding of gravity is incomplete, that the universe may be governed by deeper laws yet to be revealed. What makes dark matter truly profound is its role as a paradox. It is both nothing and everything. We cannot see it, yet it defines the visible. It does not emit light, yet it gives light a stage on which to shine. In a sense, dark matter is the cosmic equivalent of silence, the quiet background that allows the music of existence to be heard. Without it, the universe would be chaos, stars scattered, galaxies unformed, beauty lost. It is the invisible builder, the hidden hand that sculpts creation, the foundation upon which every sunrise, every atom, every moment of awareness rests. The first light that still reaches us. When we look into the night sky, we are not seeing the present. We are looking into the past, into the faint memories of the universe itself. Every glimmer of starlight, every distant galaxy, every whisper of radiation carries a story billions of years old. Some of that light began its journey before our planet even existed. Some of it comes from the first stars that ever burned. This ancient light, stretched and softened by the expansion of space, is still reaching us. Astronomers call it the cosmic background light, the faint glow that remains from the universe's earliest moments. There are two primary kinds, the cosmic microwave background, CMB, and the cosmic infrared background, CIB. Together they form a bridge across time, allowing us to glimpse the first flickers of illumination that ended the long cosmic night. The CMB is the faint afterglow of the Big Bang itself, the oldest light in the universe. It was released when the cosmos was only 380,000 years old, at a time when it finally cooled enough for atoms to form and light to travel freely. Though it now appears as a dim microwave signal, it once blazed across the young universe with the brilliance of a sun. It is not a remnant of stars, but of creation itself, the very first light that could move unimpeded through space. Every photon of the CMB has been traveling for 8 billion years, stretched by cosmic expansion until its wavelength grew 1,000 times longer. It fills every corner of the sky equally, a quiet reminder that the entire universe shares a single origin. If you tune a television to an empty channel, a small fraction of the static you see is that ancient radiation, a ghostly echo of the beginning of everything. But beyond the microwave glow lies another, more recent relic, the cosmic infrared background. This light was born hundreds of millions of years later from the first stars and galaxies that ignited during the cosmic dawn. As their ultraviolet light traveled across the expanding universe, it was stretched into the infrared range, invisible to human eyes but detectable by powerful telescopes like the James Webb Space Telescope. When Webb peers deep into the cosmos, it captures this ancient light, faint red smudges that are, in truth, entire galaxies seen as they existed more than 13 billion years ago. Some of them are so distant that their light began its journey when the universe was less than 1% of its current age. Each image is not just a photograph, it's a time machine. Through this light, we witness the first galaxies forming, the first stars dying, the first black holes awakening. We see the moment when darkness surrendered to illumination. We are not observing something long gone. We are participating in its ongoing arrival. The photons that began their journey at the birth of time are only now completing it in our eyes. And there is something poetic in that. The same universe that once shrouded itself in darkness is now revealing its secrets through the light that never stopped traveling. Every particle of that light carries information about temperature, density, composition, and motion, encoded like a cosmic message written across space-time. In decoding that message, humanity has learned not only about the origins of galaxies, but about the nature of existence itself. We've discovered that time and space are inseparable, that gravity bends light like glass, and that the universe is still expanding faster and faster into the unknown. That faint light, ancient, cold, and nearly forgotten, is the universe remembering itself. It is the echo of its first thought, the first words spoken into the void. And as long as we continue to listen, the universe will continue to speak. When galaxies collide, the dance of creation. Across the vastness of the universe, nothing stands still. Every galaxy, including our own, is moving through space at hundreds of thousands of kilometers per hour. Over cosmic timescales, these movements lead to encounters so massive, so transformative, that they redefine the shape of existence itself. Galaxies collide, merge, and are reborn. And from that chaos, new beauty emerges. When we think of a collision, we imagine destruction. But when galaxies meet, it is not a violent crash of solid bodies. The distances between stars are so immense that they rarely collide directly. Instead, their gravity weaves them together in a grand, slow-motion dance that can last for billions of years. Their shapes distort, their stars are flung into sweeping tidal streams, and new waves of star formation ignite as clouds of gas compress and collapse. It is a performance choreographed by the laws of physics, elegant, powerful, and unstoppable. The Milky Way is part of this cosmic ballet. Even now, it is moving toward our neighboring galaxy, Andromeda, at more than 100 kilometers per second. In about 4 billion years, they will merge into a single, enormous elliptical galaxy. A new creation astronomers have already named Milkomeda. Our descendants, if they still exist, will look up at a night sky ablaze with 10 times as many stars. This process of collision and merger is not an exception. It is the rule. Galaxies grow by consuming one another, absorbing smaller systems in an endless cycle of death and rebirth. Every large galaxy carries within it the remnants of dozens of smaller ones, ghosts of ancient collisions still visible as faint stellar streams in their halos. Even our own Milky Way shows the scars of its past mergers. its disk rippled by the gravitational memory of galaxies long absorbed. During these encounters, the supermassive black holes at the centers of colliding galaxies are drawn toward one another, spiraling closer over millions of years until they finally merge. When they do, they release gravitational waves, ripples in space-time that travel across the universe. Each one is a silent announcement that two cosmic giants have become one. Ironically, these collisions, seemingly destructive, are responsible for much of the universe's beauty. They trigger starbursts, forming tens of thousands of new suns in a single event. They rearrange galactic structures, create magnificent spiral arms, and sometimes even eject stars into intergalactic space, sending them wandering forever through the void. Out of turmoil, new order arises. And yet, there's an undeniable poetry in this violence. The universe does not shy away from collision. It creates through it. Without these encounters, galaxies would remain small and dim, stars would form less frequently, and the cosmic web would lack its brilliant nodes of light. The very fabric of creation depends on interaction, on the exchange of energy and matter, on the dance between attraction and transformation. Even now, telescopes like the James Webb Space Telescope are capturing the light of ancient collisions, galaxies colliding just a few 100 million years after the Big Bang. Some of those mergers may have formed the first massive galaxies, or even accelerated the birth of the earliest black holes. The dance began almost as soon as the universe learned to move. And perhaps this process mirrors something deeper, a universal principle that echoes across scales. Just as galaxies collide to create something greater, so too do ideas, lives, and worlds. Growth is never peaceful. Creation demands contact. When galaxies collide, they do not end. They become something new, brighter, stronger, and more complete. In their embrace, the universe remembers that even destruction can be an act of love. The light that became life. Every atom in your body was once part of a star. The iron in your blood, the calcium in your bones, the carbon in every cell. All of it was forged in the hearts of suns that lived and died billions of years before Earth was born. You are not separate from the universe. You are its continuation, the living expression of light that learned how to think. When the first galaxies matured, they became factories of creation. Generations of stars lived and died, each cycle enriching space with heavier elements. Over billions of years, that stardust began to gather into planets, spheres of rock and ice orbiting new suns. In one small corner of one ordinary galaxy, a planet formed at just the right distance from its star. It was neither too hot nor too cold. It had water, atmosphere, and the raw chemistry of possibility. That planet was Earth. But the emergence of life here was not a random accident. It was the continuation of the same process that began at the cosmic dawn, matter organizing itself into ever more complex forms. From the fusion of hydrogen came carbon, from carbon came cells, from cells came consciousness. The pattern never stopped evolving. Light was the first architect of life. It provided the energy that drove the chemistry of existence. Ultraviolet radiation split molecules, triggering reactions that built the foundations of biology. Later, sunlight became the power source of photosynthesis, the process that transformed Earth's atmosphere and filled it with oxygen. Life didn't just adapt to light. It became light, capturing, transforming, and radiating it in endless forms. Even now, every living thing on Earth is sustained by that same cosmic energy. The warmth you feel from the sun is the same fire that once blazed in the first generation of stars. The photons striking your skin today are the descendants of that primordial light, the same light that first broke the universe's darkness. Science tells us that we are the result of billions of years of evolution, but there's a deeper story beneath the data, a story of continuity. The universe has been moving toward awareness since its beginning. Every star that lived and died contributed to that trajectory. Every explosion, every collapse, every photon that crossed the void was part of a single, unfolding narrative, the universe seeking to know itself. Life is not an interruption in the cosmos. It is the cosmos becoming aware of its own existence. That awareness did not end with humanity. We are simply one chapter in a story that began with hydrogen and will continue long after we are gone. Somewhere out there on worlds we have yet to find, light has followed the same path. It has condensed, burned, died, and reassembled into new forms, perhaps even into new consciousnesses, staring into their own skies and wondering, as we do, where it all began. And if the pattern of the universe is consistent, if creation, destruction, and renewal are its eternal rhythm, then life is not rare. It is inevitable. We are the children of stars, the heirs of ancient fire. The atoms that once illuminated the early cosmos now think, feel, and dream through us. We are the witnesses of light's evolution, from cosmic dawn to human awareness. And one day, when the stars fade and galaxies dim, perhaps life will find another form, a way to carry that light forward once again. Because the story of the universe is not just about expansion or entropy, it's about transformation. The light that became life will never truly die. It will only change its shape, just as it always has. Echoes of the first dawn, light as memory. Light is the universe's oldest witness. Every photon that travels through space carries a fragment of time, a record of where it came from and what it has seen. The universe may forget, but light does not. It moves endlessly, weaving memory into the fabric of space itself. When we gaze into the cosmos, we are not observing the universe as it is, but as it was. The further we look, the further back in time we go. The light from our nearest star, the Sun, takes 8 minutes to reach us. From the nearest galaxy, Andromeda, it takes over 2 million years. And from the edge of the observable universe, light has been traveling for more than 13 billion years, since the dawn of creation. This makes light not just energy, but testimony. It is the record keeper of everything that ever was, an archive written not in words, but in wavelengths. Every beam of starlight is a message, every flicker a story. Some of that light, the faintest and oldest of all, is the cosmic microwave background, the residue of the Big Bang itself. When scientists capture its signal, they are listening to the first whisper of existence, the echo of a universe just beginning to take form. In those delicate patterns of radiation lie the fingerprints of the first atoms, the seeds of every galaxy, and the map of how matter first learned to organize itself. But light holds more than history. It also shapes memory. Just as the human brain stores experiences through neural connections, the universe stores its past through photons. When a star dies, its light continues traveling through space, long after its source has faded. When galaxies collide, the light from that event travels forever, carrying the trace of its violence into eternity. Every image captured by our telescopes is an intersection between now and then, the living moment touching the immortal past. In a sense, the universe is made of memory. The cosmic web is a vast network of recollection, its filaments glowing with light from stars that no longer exist. Even darkness is filled with these invisible echoes, photons stretched beyond visibility, still moving, still carrying the record of what once was. The James Webb Space Telescope has become our instrument of remembrance. Its mirrors collect the faintest photons, some that began their journey over 13 billion years ago, and reconstruct them into visible form. When we see those distant galaxies on our screens, we are resurrecting ancient light. We are giving the past a face. This act of observation connects us directly to the first dawn. The same photons that left those primordial stars now strike our detectors, and through them, our eyes. We are, quite literally, touching the light that was born when the universe first awakened. That contact collapses time, the ancient and the present coexisting in a single silent encounter. Perhaps that is the true nature of existence, not a linear march from past to future, but a continuous resonance. The universe replaying its own song through the endless motion of light. Every dawn, every birth, every flicker of consciousness is a verse in that same melody. Light may fade, but it never truly disappears. It stretches, cools, changes form, but its essence endures. In that endurance lies the universe's greatest secret. Nothing is ever completely lost. Not stars, not worlds, not even the memory of their light. We too are part of that echo. The photons reflecting from our eyes, the signals we send into the sky, the warmth of our own small fires, all become part of the universe's record. We are not just observers of light, we are its continuation. And in that realization, the universe becomes something more than a vast expanse of matter and energy. It becomes a memory of itself, endless, eternal, and still unfolding. The endless beginning. Approx. 5,200 characters. The story of the universe has often been told as a timeline, a straight line stretching from the Big Bang to today and someday to its end. But what if that story is incomplete? What if there was never a true beginning, and there will never be an end? What if existence itself is cyclical, a heartbeat echoing through eternity? Physicists and philosophers alike have begun to question the idea of a single creation event. The Big Bang may not have been the start of everything, but a transition, a transformation from one cosmic state to another. In that view, the universe did not appear from nothing. It was reborn from something that came before. Some theories propose a cyclic universe, one that expands, contracts, and expands again in an endless rhythm. Each collapse gives rise to another explosion, each death another creation. Matter becomes energy, energy becomes space, and time itself resets, like a cosmic pulse. This model suggests that the beginning we call the Big Bang was simply the latest in an infinite series of awakenings. Others imagine a multiverse, where universes emerge like bubbles in an infinite sea, each one a separate expression of the same underlying reality. In that sense, the cosmic dawn wasn't a singular event, but a local sunrise, one among countless others illuminating their own skies across the eternal expanse. Even quantum mechanics hints at something cyclical. On the smallest scales, particles do not behave like isolated objects, but as waves of probability, constantly appearing, vanishing, and reappearing. Reality itself flickers, creation and dissolution happening simultaneously. The universe, at its core, might not be linear but oscillating, forever balancing between being and becoming. If that's true, then every end, every death of a star, every fading of a galaxy, every collapse of matter into darkness is not a finality, but a preparation. The energy released in those endings may one day ignite a new reality, another dawn. The light we see across the cosmos could be the lingering embers of previous universes, their memories carried forward through time. In that perspective, existence becomes less a story and more a cycle of remembrance. Every pattern in nature reflects it, the orbits of planets, the seasons of Earth, the beating of a heart. The cosmos repeats itself at every scale. The birth of galaxies mirrors the birth of cells. The fusion of stars mirrors the spark of thought. The rhythm of life and death is the same rhythm that began with the first pulse of creation. Perhaps the truest description of reality is not that the universe began, but that it is always beginning. Every moment, every breath, every flicker of awareness is part of the same unfolding. The cosmic dawn never ended. It only shifted from hydrogen to light, from starlight to life, from life to consciousness. The dawn became us. And that realization changes everything. It means that we are not observers at the edge of an ancient story. We are the continuation of it, the living proof that the universe is still evolving, still experimenting, still discovering itself. Every thought we have, every act of creation, every question we ask extends that original spark. If there is an endless beginning, then the universe is not moving toward an end, but toward understanding. Its purpose is not to vanish, but to become aware, to illuminate itself over and over again. And maybe, long after our stars fade and our galaxies drift apart, that awareness will ignite once more, elsewhere, in another reality, another form, another dawn. Because the universe was never designed to end. It was designed to awaken again and again forever. The universe remembers its own light. At the end of this journey, Beyond stars, beyond galaxies, beyond even time, something remains. It is not matter, nor energy, nor space. It is memory. The universe remembers its own light. Every atom that has ever existed still carries the echo of that first dawn. The hydrogen that once blazed in the hearts of ancient suns still drifts between galaxies. The photons that burst forth from the first stars still travel across eternity, unchanged and unstoppable. In the deepest sense, nothing in the universe is ever truly lost. Everything endures as light transformed. And perhaps that is the ultimate revelation, that the cosmos is not a story of beginnings and endings, but of remembrance. From the first spark to the last whisper, it has been teaching itself to recognize its own reflection. In the shine of a star, in the rhythm of an orbit, in the awareness of a living being who dares to look up and wonder. When we study the sky, we are not just observing the universe, we are participating in its memory. Every telescope pointed at the heavens, every photon captured, is the universe recalling a forgotten fragment of itself. In that act of observation, creation becomes conscious. Humanity is the universe remembering that it can see. It took 13.8 billion years for stardust to arrange itself into something capable of asking where it came from. And now, through our eyes, the universe looks back on itself and understands. We are not separate from the stars. We are their continuation, the living consciousness of cosmic light. That understanding gives every human act, every moment of awareness, profound significance. When you look at the night sky, you are seeing the earliest light of creation. But when the universe looks through you, it sees its latest. You are both observer and observed, both the echo and the source. And so the story circles back to where it began, in darkness. Not the absence of light, but its foundation, the quiet stage upon which illumination unfolds. The darkness is not the enemy of creation. It is its memory, holding the record of every spark that ever existed. Without it, light would have no contrast, no purpose, no meaning. Perhaps the purpose of the universe was never simply to exist, but to remember, to trace the path from the first fire to awareness, from silence to song, and in doing so, to discover that all of it, the galaxies, the atoms, the thoughts, the dreams, are different expressions of the same light returning to itself. That is what it means for the universe to remember. It means that you, right now, are part of that remembrance, a momentary consciousness through which the cosmos recognizes its own beauty. When the last stars fade and the galaxies drift apart, when light itself grows thin and time begins to unravel, that memory will not vanish. It will remain, perhaps as energy, perhaps as something we have no words for, waiting for another dawn. Because light has always found a way back. Finally, when the next universe awakens, when the silence breaks once more and the first spark ignites in the darkness, it will not be a beginning born from nothing. It will be a continuation of everything that ever was. The universe will remember, and it will shine again.